The question is saying that a heating element using nichrome connected to a 230 volt supply draws an initial current of 3.2 ampere which settles after a few seconds to a steady value of 2.8 ampere. What is the steady temperature of the heating element if the room temperature is 27.0 degrees centigrade? The temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.7 into 10 to the power minus 4 per degree centigrade. Now this question is using temperature dependence of the resistor, which is given by the mathematical formula RT, resistance at temperature T, equals to R naught, that is the reference temperature resistance, multiplied by 1 plus alpha, that is temperature coefficient of resistance, multiplied with delta T, or final temperature minus initial temperature, or the reference temperature. Now in this question we have been given the potential difference, that is constant in this temperature range, I naught, initial current through the resistor, IT, that is the final current through the resistor, initial temperature we have been given, and the temperature coefficient we have been given. So we have to find out what is the steady temperature, that is T final we have to find out. T initial is given and we have to find out T final. So calculating the initial resistance, we can use this formula V by I. Since potential difference is same, so V would be equal to 230 and initial current is 3.2 ampere. So we will get R naught, or the initial resistance, as 71.875 ohm. Now final resistance we can also calculate, which can be calculated using the same formula, just using the final current, or the current at temperature T. We will get a value of 82.143 ohm. Now we know RT, that is the final resistance, R naught, we have been given alpha, we have been given T naught, we also need to find out T. So substituting the values, we will calculate for T, that is the final temperature. Now T will be 867 degrees centigrade. Thank you.